Good evening and welcome to Foundations for Algebra, Unit 4B, Lesson 2. Today's objective, scholars will understand exponential growth and decay. Make sure that you're looking at your notes while we get through this. So, first, what is exponential growth? So, exponential growth is when a quantity is increasing by a specific percentage or ratio. So remember, linear, we increase by a set number. Here it increases by a set percentage or ratio. So the rate of change increases as the function increases. When you look at this graph, this is exponential growth, you'll notice it starts out little, and then it starts growing, and it keeps increasing how quickly it's growing. That's why the line keeps getting steeper and steeper and steeper. So some examples of things that would have exponential growth are compound interest. We talked about that some when we went over our financial unit. Bacteria growth and the spread of different viruses, especially like computer viruses. Next, we have exponential decay. So exponential decay is sort of the opposite. So this is when a quantity is decreasing by a specific percentage or ratio. So in this case, the rate of change decreases as the function increases. You'll notice on this graph, it starts out decreasing very quickly, and then it slows down and starts decreasing more slowly. So some examples of things that would have this type of exponential decay are things like the half-life of radioactive elements, bacterial decrease, and depreciation. That's when the values of things go down every year, like the value of a car or a cell phone. So what do the equations for exponential increase or decrease look like? So we got our y equals, we're used to that, we're used to the x, except look where the x is. In this case, the exponent of x is what makes this an exponential function, having that exponent of x. So b is the amount of growth or decay, and you'll notice when b is greater than 1, it is growth. When b is less than 1, it is decay. And then a, this number right here, represents our y-intercept. The y-intercept is at the point 0, comma a. That is our beginning, just like the y-intercept of our linear functions was our beginning. So let's talk about how we can find our rate of increase or decrease. So when we're looking at this, we're going to look at this table. And I can see here, that's a bad color. Let's see this one. I can see here that it starts out at 3. So 3 times what gives me 4.5? So 3x equals 4.5 is how we can do this. Because I figure out what I'm multiplying it by. So if I divide both these by 3, I get x equals 1.5. And then I double check and make sure that 4.5 times 1.5 gives me 6. And actually it won't. This one's actually a linear, because this one's actually increasing by 1.5 each time. So this one would actually be linear. We'll talk about distinguishing them again. Okay, so let's look at the next one. So I made a mistake there. Sorry, guys. But that's a linear equation. You guys know how to do that. We have our rate of change of 1.5. We keep increasing by 1.5. Okay, so the next one. Here, 16 times what equals 8? Well, if we divide 8 by 16, we get x equals 1/2, 0.5. Well, 8 times 0.5 also gives me 4. I know that. 4 times, it looks like I'm dividing by 2, but remember, we're never dividing, we're multiplying. So here, my percentage of change, my ratio of change, so here b would equal 0.5, because I would be multiplying by 0.5 to go from each to the next. And I can see my starting point right here, so I can write this equation. So when I go to write this equation, I have my starting point. So remember, it was y equals ab to the x. So I found b is 0.5. A is going to be this value right here. So this one is y equals 16 times 0.5 to the x power. Okay, so let's look at the next one. Let's do this one with green. So here, I'm going to move this over so I can show you guys a little bit easier. Okay, So here, notice I start at 1. So this means y equals 1 times b to the x. So I need to figure out what am I multiplying to get from 1 to 3, then 3 to 9. Well, I'm multiplying by 3. So this is y equals 1 times 3 to the x power. And if you put these in, you get the same numbers. So there's our equations. If we wanted to go back and write an equation for the linear one, our starting point was 3. So this is just y equals 1.5x plus 3. Remember that. Okay, so now let's talk about writing an equation for a situation. Remember that A is our starting point and B is our rate of increase or decrease. So first, let's look at this first one. I invest $500 in an account with 5% interest. So this is definitely increasing. So that means that B must be more than 1. So I have 5% interest. We write 5% as 0.05. But that's less than 1, so that doesn't work. So when I'm multiplying it, I actually want 1.05 because I get to keep the original money and then increase it. So that is my B, and here's my A. So this one is just y equals 500 times 1.05 to the x. Let's look at the next one. There are 128 grams of uranium decaying, that means I'm decreasing, at 10% per year. Well, 10% is going to be 0.10. But remember, just like we added the 0.5 to the 1, here we're going to subtract the 0.5 from the 1. So 1 minus 0.10 gives me 0.9 as my rate. Notice that's less than 1, so it'll be decaying. So this one is just y equals 128 times 0.9 to the x. And our last example, I start with 5 bacteria. The culture triples each day. So here's my starting point. So y equals 5 times, culture triples. Triple means times 3. So 3 to the x. Okay, so go ahead and try these on your own, and I will see you in class.